So let's continue our discussion of section 8.3 with the section in your notes that says confidence intervals and hypothesis tests. So confidence intervals and hypothesis testing are very, very closely related. They're both under the umbrella of inferential statistics, and the goal with both of them is to make some prediction about what we think is true for a population based on a sample that we select from that population. What's really different is the questions that they ask. So when we talk about a confidence interval, remember a confidence interval gives you a range of plausible values for a population. Like before an election, we might say we are 95% confident that the proportion of people in the state of Florida who are going to vote for a certain candidate is between 40 and 60%. That would be a confidence interval. So that gives us a range of plausible values for the population. The question then for a confidence interval might be something along these lines. Let me use the red pen. What is the value of the parameter? So in other words, what are some plausible values that may be true for the parameter? And that's where we give a range of values, that we think the parameter proportion is from 40 to 60% or whatever. So confidence interval is what is the value of the parameter? What do we think is the value for the parameter for the population? Hypothesis testing you can think of as more of a yes or no question. Hypothesis testing you can think of as asking the question, are the data that you're looking at for your sample, are the data consistent with, I'm going to abbreviate, with the population parameter? Like, do we think the parameter is at 40%? Or might the parameter be different or be something else, be different? Okay, so it's more of, like I said, more of a yes or no question. Is the data, or are the data, it's a plural term, are the data consistent that I've taken from my sample, is that consistent with what I think the population proportion might be, or does my sample indicate that the population proportion might be something different? That's the question with a hypothesis test. And so when you're deciding which one to use, it's based on what the question's asking you. So even though they're designed to answer different questions, they are similar enough that they lead us to reach the same types of conclusions. So a confidence interval can lead us to some type of conclusion, to the same type of conclusion rather, as a two-sided hypothesis test. So this chart gives you a little bit of the relationship between a confidence level, remember confidence level would be like 90%, 95%, or so forth, and a significance level for a two-sided alternative hypothesis test. If I have a 90% confidence interval, for example, that would coincide with a two-sided hypothesis test with a significance level. So remember, your significance level is alpha. So that would mean your significance level for your hypothesis test would be 10%. A 95% confidence interval would correspond with a 5% significance level for a two-sided test. And a 99% confidence interval would correspond with a 1% two-sided hypothesis test. So let's look at an example and see if we can kind of put this together. So example 4 says, in 2015, the Pew Research Center estimated that 56% of Americans support the death penalty. So the way this is phrased, they're stating this as this is the population proportion. This is what they think the population proportion was in the year 2015. So I'm going to jot that down. That would be P equals 56%. In 2016, a Pew Center poll found that 49% support the death penalty. Suppose the 2016 poll was conducted on a random sample of 1,201 respondents. So do we have evidence that support the death penalty has changed among Americans since 2015? So the idea here is that we have this population proportion from 2015 that says the proportion of support was at 56%. We did a new poll in 2016, and in that sample for our new poll, we found that only 49% support the death penalty. So the idea is that what we're interested in is, has the population proportion actually decreased from that 56%, or is it just by chance that our sample happened to be a little bit lower than the 56%? That's what the hypothesis test will tell us. So part A says use a 5% significance level. And again, it's like a yes or no question. Has the population proportion actually decreased based on our sample? That's what we're interested in figuring out. So let's go ahead and write our hypotheses first. So the null hypothesis is that nothing has changed. It's the status quo. The population proportion is still at 56%. So P is still at 56%. The alternative, remember, is based on the way the question is phrased. And because they're saying, do we have evidence that support of the death penalty has changed? So let's think about that. Has changed. That means has gone up or gone down. It didn't say has decreased. It said has changed. So that means it could have been higher or lower. So my alternative in that case would need to be that the P does not equal 56%. The prepare steps I'm going to kind of go through quickly because I told you all of these would fit what we needed them to fit in order to run the hypothesis test. It's a large enough sample. They told us it was a random sample. It's 1,200, so it's certainly large enough. So it's random and independent, large sample, and also large population. Large sample, large population. Okay, so then let's go ahead and get ready to compute what we need to, and we're going to use StatCrunch to figure this out. So I'm going to show you in class, and I'll do a video of this sometime, probably on Monday when I do the Zoom session, going over how to run this stuff in StatCrunch. But when we go to StatCrunch and put this information in, here's what it's going to tell us. So remember that our sample size was 1,201. P hat, by the way, let me go back for a second. P hat is based on our 2016 poll, and that P hat value is 49%. So P hat, I'm going to just jot that down, is 49%. So in StatCrunch, you have to put the number of successes. So the number of successes would be 49% of 1,201, and that amount would be 588 out of 1,201, and that gives me a sample proportion of 0.49. And as it should, because that's where we got it from. The standard error from StatCrunch, it is 0.0143. And then the test statistic from StatCrunch is negative 4.92. The p-value that goes with that. Now, before I tell you what the p-value is, I want you to think about that. You've got a z-score of almost 5 standard deviations, right? 5 standard deviations below the mean because it's negative. What do you think that tells you then for your p-value? That's pretty far out into the extremes. That would be way, way out in this tail at around negative 5. And your p-value would be below that. Remember, this is a two-sided hypothesis test, so you would also have to include this side. So both of those together would be your p-value. But the main thing I want you to think about is if you're below 5 standard errors below the mean, that's going to be a really, really, really small area. It's almost going to be 0. For all practical purposes, the probability is really 0. So what StatCrunch does is it tells you the p-value is less than 0.0001. So it's a very, very small p-value. So what does this tell us? What's the interpretation? Well, they didn't give us an alpha, they did give us an alpha level of 5%. What I was going to say was it doesn't even really matter because the p-value is so small. I mean, smallest alpha level you would have is 1%, and we're still well below that. So what can we say? Since the p-value, and I always like to write the word p-value, the p-value is less than the alpha level, that means what? That means we can reject the null hypothesis. And so remember, the null hypothesis was that the proportion of people who support the death penalty is still at 56%. So what does this indicate? This means, let's see, we can reject null hypothesis. Let's see, we would conclude that there is evidence that the death penalty, people who support the death penalty, so the death penalty support has changed from the 56% that we thought it was in 2015, I think it was. Okay, so this gives us evidence in support of the alternative hypothesis because we have such a small p-value. Now, part B of this question said construct a 95% confidence interval for the proportion of Americans who still support the death penalty. So we would also do this in StatCrunch. And if we go to StatCrunch, it's the same information. We get to it in the menu the same way. We just check confidence interval instead of hypothesis test. And so it's 588 out of 1201 again. and the sample proportion is still 49%. The standard error is the same, 0.0143. And our lower limit and our upper limit from StatCrunch is going to be 0.46 and 0.52. So my confidence interval goes from 46% to 52%. So what does that mean? Let me go ahead. I've got some a sentence at the bottom here, but I'm going to write it in here. So how would we say this? We would say we are 95%. So we are 95% confident. So remember, this gives us a range of plausible values for a population. So we're 95% confident that the population proportion who support the death penalty is between, so penalty is between, let's see, 46% and 52%. Okay? So we're 95% confident that the proportion who really support the death penalty based on this new data that we have in 2016 is between 46 and 52%. So does that support what we said about the hypothesis test? So remember, the hypothesis test said that does this, that we have changed from the 56% in some way. So absolutely, this supports that. How do I know this supports that? Because we're saying in the hypothesis test that that the population proportion is no longer 56%. Well, your confidence interval says we think it's between 46 and 52%. Notice what number is not in your confidence interval. 56%, right? So I don't have room on here, although I think you have it in your notes somewhere. It says something about how do these two things compare? Does this support the hypothesis test? So yes, this absolutely does support the hypothesis test. So if you want to jot that down somewhere. Yes, this supports the hypothesis test. All right. Let's take a look at example 5. Students are completely attached to social media. I decided to run a test of hypothesis to test the claim that the majority of all Flagler College students visit their Facebook account daily based on a class survey. The results of the test were as follows. Explain the p-value in the context of this exercise and state the conclusion. So here's my screenshot from StatCrunch. Notice that my sample proportion is about 54.6%. My standard error is about 0.0577. My test statistic is only 0.808. So think about, do you think that is unusual? And hopefully you say no, because that is still within 2 standard errors of the expected proportion. The expected proportion based on the hypothesis test was 50%. And my p-value is 0.2095. So what do you think about that p-value? That is a large p-value, right? That's almost 21%. So that would mean that we do not reject the null hypothesis. Let's put all this together. So there is a blank percent chance of getting a sample. So we're describing the p-value. There is a 20.1% chance, that's the p-value, of getting a sample of college, that's the word here, it's just college students, where 55%, because 55% is my sample proportion, where 55% or more of students visit their Facebook account daily if the true percentage or the real percentage of all students who visit their Facebook account daily is actually 50% or less. So let's say all that again. Remember what the p-value is. It is the probability of getting your sample, the statistic for your sample or something more extreme, if the null hypothesis is true. If we drew a picture of this, what would we say? We would say, okay, the null hypothesis is 50%. That's right here. My sample proportion is 55%, so that would go right here. And because the alternative is a right-tailed test, because the alternative is that p is greater than 50%, in my shading, I would shade everything to the right of my test statistic. And so what I've just shaded is my p-value. Remember, p-value is a probability. So there is a 20.1%, that's the p-value, chance of getting a sample of college students where 55% or more visit their Facebook account daily if if the true percentage of students who visit their Facebook account daily is only 50% or possibly less. That is a very large probability, right? That means we are not surprised. That means the 55% is just due to sampling variation. It doesn't mean that the proportion is actually higher than 50%. So let's put this together. What could we say to conclude this? We would fail to reject the null hypothesis since P is large. Again, they didn't give you an alpha significance level, but P is large. 21% is a large p-value, so you don't have to worry about that. So the resulting sample of 55% is not unusual. Okay, so what does this mean? What does this mean? Well, I've got some room on the next page here. So what does that mean? We cannot reject H naught. So there is insufficient evidence that more than 50% of students check Facebook daily. All right, and so that's what the hypothesis test is here. Okay, last question. Are the public libraries in the U.S. a thing of the past? A Pew poll in 2015 estimated that only 44% of Americans had visited a public library in the previous 12 months. So while I realize that's based on a poll, they're stating it as an estimate of all Americans. So that's going to be our population proportion, is 44%. Suppose you were doing a project in which you want to determine if the proportion of Americans who had visited a public library in the past 12 months has declined. So pay attention to that word. Suppose you give a survey to 100 randomly sampled St. Augustine residents and find that 42% of those in your sample say that they have attended a public library within the past 12 months. So just to make a note, that's your p hat. So I'd write that down if I'm working the question. I start to write these things down on my paper so I can keep straight what's happening in the problem. Let's see. You decide to use a significance level of 5% and carry out a hypothesis test with the results shown below. Based on this, you claim that you have proven that there has been no decline in library attendance. What mistakes have you made? Well, first of all, let's look at the results. So your null hypothesis is that P is still at 44%. The alternative is that P is less than 44% because the question said, has the population proportion declined? The results are given in the table below, and you notice a couple of things. First of all, our test statistic, our z-score, is only negative 0.4. It's negative because my sample proportion was below the expected 44%. But is that unusual? No, not unusual because it's still within 2 standard errors. So this is not unusual because it's still within 2 standard errors of the expected 44%. Accordingly, the p-value then is quite large. The p-value is only 34%. Remember, test statistics closer to 0 provide larger p-values. So I would say that yes, we're correct in that we do not fail to reject the null hypothesis, but do we ever use the word proven? No, we do not. We always have uncertainty. Remember, statisticians always have that out because of the uncertainty. So the issue is that we don't want to say proven. So what's the mistake? I would say don't say proven when you state your conclusions. A better way to state the conclusion would be something along these lines. There is insufficient evidence that attendance has declined. So attendance at libraries has declined. So what that means is that our sample is just by chance, that if the population proportion is still 44%, it would not be unusual for us to get a sample with 42%. It's just because of sampling variability. And so that means that we don't have evidence that the population proportion has actually declined.